Okay, here we are on the second part of the graphing from, or I should say, the second part of the worksheet from today, which is on graphing. So, we've got three problems. Really, we've got more than that, but we'll do three together. And we've got two versions of slope-intercept form and then point-slope. So we'll do the odds together, and then you'll do the evens for homework. So if you read the directions, it says graph each of the following lines, indicate the point or intercept given, and the slope before graphing. I had mentioned in class today, I think one of our biggest issues on the last quiz was we didn't have a good grasp of what were the two pieces of information you needed. Where did you have to start your graphing? And then the slope part was okay. As I said, a lot of people graphed parallel lines. So, meaning they just started at the wrong place, but used the slope correctly. So, what I usually tell people for this is what you want to do is first you want to recognize what form you have. And I know that if I see anything y equals, it's slope-intercept form. And then to write that equation above or below the equation you're being asked to graph. That's going to help you more easily identify your slope and your y-intercept. The slope always goes where m goes. It said that at the top of the front page. Slope is m. So m equals 3, and we talked about putting it over 1. Slope always has to tell us two things. The change in y, that's the y2 minus y1, over the change in x, x2 minus x1. So the slope most properly is a fraction. Numerator tells us how far to go up, down if it's negative, and then to go over to the right from the denominator. Okay, and then the other thing here obviously would be b, would be the y-intercept. In this case, I'm going to write that as the 0.05. Okay, that's all the information I need. I'm ready to graph this. I know that it's 0.5 because that's where a point on the y-axis should be. I know the y is the vertical axis. It's labeled right here for me. So, if I'm graphing 0.5, I don't go anywhere left to right, right? That's what it means to be 0, but I do go to 5, right here. My slope of 3 tells me that my change in y should be 1, 2, 3 spaces up. Over 1 tells me to go 1 space to the left, and that's another point. And then from there, I would connect the dots to make my line. I certainly could continue going up 3 and over 1 and make more points, but I really only need 2. Okay, let's look at another example of slope-intercept form. Let's look at number 9. Number 9 I know is again slope-intercept form, y equals mx plus b because it's y equals, but I notice there's a little something different going on. M is 4, so my slope m is 4 over 1. But notice when I try looking for b, I'm just highlighting empty space there. That doesn't mean there isn't a y-intercept. We talked about the fact that I only have a horizontal or vertical line if it's y or x and a number. If I have both variables, I will have a slanted line, a slope and a y-intercept, or a slope and a point. Well, if it's not there, then it must be 0. 0, 0 is my intercept. You can think of that as saying kind of plus 0 after that x. If they intend for me to have a y-intercept other than 0, they'll tell me plus 2, plus 1, minus 5, and so on. If they intend for me to have a 0, they just won't put it because we know at the end of the day that's an expression that we would have to simplify, and y equals 4x plus 0 and y equals 4x would simplify it to the same exact expression because addition with 0 doesn't change anything. We talked about that last year, also probably before high school. All right, so I'm going to plot the point 0, 0 at the origin. My slope of 4 tells me to go up 4 and to the right 1. Again, because it's positive, I go up, and then I connect the dots to form that line. Okay, let's take a look at some point slopes, since these seem to be more problematic than others. Point slope formula, now certainly I can make this into slope intercept, but I would like you to be able to graph from point slope as well. I know it's point slope because I see parentheses and because I see y minus 2 instead of y equals. So I'm going to write down point slope form above the equation. Okay, so I need to identify my slope. It is still m, so I've got m equals 3 over 1, similar to my first problem. Then I have the point now. I don't have an intercept, I have a point. And it's going to be my point x1, y1. The same points we were using in the other video to write the equation on the first page. So, I have to identify those. And I've got x1 here and y1 here. Now, remember that for point slope, when I go to write the coordinates, x, y, it's always going to be the opposite of what you see. You see an operation. For example, with x1, I see x plus 1. The coordinate itself is going to be the opposite of what that tells me. It tells me plus 1. It means my coordinate is negative 1. For y1, it tells me minus 2. That means my coordinate is positive 2. What you might remember is that if the formula is y minus y1 and x minus x1, if I were to plug a negative coordinate in there, I would get the double negative and have to put a plus sign. Okay, so I'm going to plot now, instead of plotting an intercept, I'm plotting a point. Negative 1, 2 is right here. And from there, similar to when I start with a y-intercept, I go up 3 and to the right 1. Same idea. The change from one point to another is up 3 and over 1. Just so happens I'm not starting on the y-axis here. And I get this line. You might recognize that as the same line from the first graph. You'll notice here that not only do I go through the same y-intercept at 0, 5, I also go through, if I go up 3 and to the right 1, I also go through 1, 8, the second point I put on the graph in the first problem we did. So that just shows you again that these are the same line. Y equals 3x plus 5 and y minus 2 equals 3, parentheses x plus 1 is the same exact line, just written in a different form. I can start at any point on that line, use the slope to find another, and graph the line just as I would if I started at the y-intercept and use the slope to find another point. All right, let's try one more point slope form problem. So I get, again, I know that this is point slope because I see y plus 1 rather than y equals. I see parentheses around the x. I don't just see x. So here we go. We have a slope, still m. In this case, it's 3 over 4. Now here I don't need to put a denominator because it already gives me 1. I know the denominator. I know the change for x. I know what x2 minus x1 is. It's 4. So I have a slope 3 over 4. My point x1, y1 is going to be similar to the last time. I know that I've got a point for x1, it's -2, so it's the opposite, so +2 is the coordinate. For y1, I've got +1, so it's the opposite, so the coordinate is -1. So now I'm going to go down here and I'm going to plot the point 2, -1. My slope is 3/4. That means I have to go up 1, 2, 3, and to the right 1, 2, 3, 4 spaces, and put another dot. And I get that. And there's my line. Now this one, I can tell you, it would not be very easy to put into slope-intercept form. Your y-intercept would be a fraction or a mixed number. Those are not easy to graph, right? Because you have to kind of guess where they go, especially when you're given axes that are pre-numbered for you like these. So while certainly going into points from point slope to slope intercept is an option, it's not always the best choice. Sometimes you really should write down your point, write down your slope, and graph using those two. And certainly it's always faster if you just use that information that you are given rather than going through the algebra to transform point slope into slope intercept form. Okay, so you can watch this again as many times as you want. As I said in the other video, the answers to these problems, if you'd prefer to read them, are posted to Schoology in the same update where you found this video. And your homework is the two remaining equations on the first page. So numbers 3 and 6, and then the evens of the graphing.